So we are now finding the derivative of trigonometric functions. And the question, I'm going to write Q for question here, and hopefully I'm sharing this and you can see this. But Q for question, I have Q for question, and I'm going to essentially write down the function that we are given that we want to actually find the derivative of. So the function that we're given is 4 sine of x, 4 sine x, and then that's multiplied with what seems to be tangent of x. And so in other words, we could replace this notation and simply say that we want to find d over dx of 4 sine of x, 4 sine of x, multiplied with tangent of x. Now, if you really analyze this particular component here, what you need to do, it will reveal exactly what it's made of, and then breaking that apart will give you a good idea of what needs to be done. So the first thing that I notice is that I have two functions. One function is here, sine of x, and another function, which is tan of x. And in conjunction to those two, I have a multiple, or not a multiple, but a constant. So first things first, I notice that I have two trigonometric functions, right? One is tangent of x and one is sine of x. And then second, I recognize that I have a constant attached to this function. So this brings me to the idea of the constant times the function rule, the derivative, the basic property, which is if you have a constant, and I'm going to write constant for c, or I'm going to write c for constant. If you have a constant times a function, and you are essentially taking the derivative, d over dx, you're taking the derivative of this particular problem, or of this particular multiplication problem where you have a constant multiplied with a function. What we do is we essentially isolate the constant. We bring out the constant. So we say that we have c out here, and that's multiplied to the derivative of the function. And after we find the derivative of the function, we simply multiply that to the constant, and that essentially gives us our derivative. So first and foremost, I would say, is let's get that constant out of the way, right? So let's bring that constant out. So we would really be left with having 4, and let me actually change the color here. So we'd really be left with having 4 multiplied by d over dx of a constant, or a constant multiplied to the derivative of what we have inside as our two functions. And you really want to treat them independently because they are independent, right? These are two different trigonometric functions, which we could, again, treat independently. And since they are both functions, I can sort of attribute names to them. So this is sort of f of x, right? And this would be this could be g of x, right? And these are just I'm not going to call them both f of x because that would confuse basically the functions together. But I'm going to call this f of x, I'm going to call this g of x. So these are just two names for both of these functions. And the idea here is that we have, so if we were to really look at this, we would really break this apart. We have a constant, which is equal to 4. We have f of x, which seems to be equal to sine of x. And we have g of x, which is actually equal to tangent of x. And so essentially, when you look at a problem like this, it looks confusing, but it's actually made up of these three parts. And we are going to leverage some basic differentiation properties to actually solve the problem. So first and foremost, it seems as though we don't need to worry too much about this 4 until the problem is almost concluded, or almost concludes. But what we do need to worry about is this particular portion here. And we worry about this portion because we don't worry, but there is a way of solving this, a systematic way of doing this. And the rule is it's the product rule. And the product rule for differentiation states that if you have f of x multiplied to g of x, then the differentiation, or d over dx, of this particular multiplication here of these two functions will actually equal the derivative of f of x multiplied to g of x plus the derivative, or actually f of x multiplied to the derivative of g of x. And if this seems confusing, you could just remember them as being u of v, right, plus u. Well, you could remember it as being u prime v plus v, or actually u prime v and then plus u v prime. But for now, for this example, let's actually follow this. Although once you do this enough, this just seems very easy to understand. But we'll look at it in terms of this because it breaks it apart rather neatly. So if we were to move on here, we could say that we would have 4, right? And we want to differentiate. Again, we want to be able to differentiate. So we would take f of x, which is sine of x, and we would take the derivative of that. That's what the product rule states. So we take the derivative of sine of x. So we would actually be doing d over dx of sine of x, right? And that would be multiplied to g of x, which is tangent, and all that would essentially be added to f of x, which is sine of x, multiplied to the derivative of g of x, which is, of course, tangent of x. And so this would essentially be our main starting point of computation. So let me actually clear the board here so that we actually have some space to work with. But this would be our initial starting point, our foundation, if you will, for actually beginning to compute the problem to some extent. So first we have a 4 out here, and then we find the derivative of sine of x. Now, if you look at the graphs, you'll actually notice that there is a graphical relevance to this, but the derivative of sine of x is actually cosine of x. And so we put that property down, and we say that, okay, so the derivative of sine of x is actually cosine of x, so we're going to have cosine of x in that place. And that would be multiplied to tangent of x, okay? And that would, of course, be added to sine of x, multiplied to the derivative of tangent, and the derivative of tangent is secant squared x. Okay, so this is essentially the same thing as saying 4 multiplied to cosine of x times tangent of x plus sine of x times secant of x, secant squared x rather. And the idea here is to use the distributive property to actually distribute the 4 across both of these trigonometric functions, which are actually multiplying themselves. So we'd have 4 cosine of x tangent of x plus 4 sine of x secant squared of x, right? And we know that tangent of x, if we revisit some trigonometry, we know that tangent of x is actually equal to the sine over, it's actually equal to the sine of x over the cosine of x. And so the idea thus is to say that this is essentially the same thing as saying 4 cosine of x multiplied to the sine of x over the cosine of x plus 4 sine of x multiplied to the secant square of x. And just so we have some more room here, let's work with our new rewritten problem. And what we can do here is we can then cancel out cosine of x with cosine of x, and then we're just left with 4 sine of x plus 4 sine of x secant square of x. Now this is significant because what we'll do here is we'll actually be factoring out 4 sine of x, something we actually have in common. And the idea here is if I were to draw a parallel, this would be in the form of a plus a times b, right? Because we have 4 sine of x here, and then 4 sine of x times secant squared of x, and we have a times b. So we have a plus a times b. And the idea here is to essentially factor out the a, because that's something we have in common. We want to write this in simplest form. And so we factor out the a, and then we compare a with the rest of the addition problem. And so we say, okay, this would be a divided by a. And since this is a times b, so this would be a times b, and we would divide that by a. Factoring is just sort of dividing through. And then this would cancel out to 1, and this would cancel out to b. And so we'd really just be left with a 1 plus b, right? And the same idea works here. So what we do is we'd say, okay, we have 4 sine of x. We're going to factor that out. And what we're going to do is we're going to say, okay, 4 sine of x over 4 sine of x. And that would, of course, be added to 4 sine of x secant square of, and actually let me put a parentheses around so that the separation between both of these functions is evident. So we would, of course, divide this with 4 sine of x. And it's the same thing as we worked out here. So 4 sine of x would cancel out, and that would simplify to 1. 4 sine of x would cancel out with 4 sine of x again, and we'd essentially be left with 4 sine of x with 1 plus secant square of x, which is the only thing that's left. So we left with secant square of x, and that would essentially be our solution.